Hello, everyone. Today, I'm going to start discussing conic sections. And the word conic section comes from the fact that if you have a cone, so if you draw a cone, let's do one quickly, or like cone would look something like that. And you cut it by a section that is perpendicular to the axis of the cone. Here is the axis of the cone. And if you take a cut like that, it will show you a circle. Do you see that? That if you have a cone and you cut it, and this cut is either parallel or parallel to the horizontal or perpendicular to its axis, you will get a circle that looks like that. If you tilt the section a little bit, it will give you an ellipse, right? And if you cut it even more such that it doesn't cut both ends, but it cuts only one end, you get a parabola. And if you cut it parallel to the axis of symmetry, it will give you half of a hyperbola, meaning if you have two back-to-back cones, so if I have another cone like that and I cut parallel, it will give me like a hyperbola. So what we are going to do today, or we start doing today, is to go over, um, maybe I'll do the circle and the ellipse today, and then we'll leave the parabola and the hyperbola for next time. But there are some stuff that we need to talk about. Let's start with the circle. A circle is very easy. All of you know the equation of a circle. We will write it again and we'll see why it is like that. So maybe that's an easier way to draw a circle. And let's say the center here is any point. Usually in math, we say it's H and K. So the x coordinate, it doesn't have to be the origin. So the x coordinate is H and the y coordinate is K. And then, like we said, always, any point on the line or on the equation would satisfy the equation of the circle. So the equation of the circle, if the origin was the center, we would say x squared. But since it's not, we moved it to a point h, then we say x minus h squared plus y minus k squared equals r squared. In fact, the idea is this divided by r squared and this divided by r squared equals 1. That's originally, or that's, if you write it like that, you would understand why the other conic sections have their equations. Of course, here, if I multiply both sides by r squared, you get the famous equation. You know that x minus h squared plus y minus k squared equals r squared. And that comes directly from the fact that you would find if that any point here on the circle is x and y, then you would say, well, we know the distance here, you know the equation of the distance, and if you take that distance and square it, you will get x minus h squared plus y minus k squared equals the square of the distance, but the distance is r, so it's very simple by applying the distance formula to get that equation. So, in fact, there is nothing more to say about that. However, sometimes you will be given an equation in this form. Ax squared plus maybe bxy plus cy squared plus dx plus ey equals 0 plus f, a constant. That's the general equation of a conic section. Now, if I don't have the xy term, the xy usually it's, well, you may see it in a parabola or when you rotate a figure, but we are not going to deal with that for the time being. Okay? If both x squared and y squared are there and the a equals the c, so both of them are the same number, then that's an equation of a circle. Okay? Later we'll do the ellipse. You will see that I have an x squared term, I have a y squared term. Both of them are positive or they have the same sign, but A doesn't equal C. If A and C are different, you get an ellipse. If A equals C, you get a circle. And then next time we'll see how you identify a parabola and a hyperbola, which is pretty straightforward. Okay, so maybe we can get an equation. I didn't prepare one, but maybe we can write an equation, for example, 3x squared plus 3y squared minus whatever, 6x plus 9y plus 4 equals 0, something like that. So the first thing I look at, do I have both x squared and y squared? If I only have one of them, it's a parabola. Okay? And then I'm going to look at the coefficients of x squared and y squared. If they are equal, it's a circle. If they are different but having the same sign, it's an ellipse. If they are different or equal, it doesn't matter, but they have opposite signs. So this is a 3 and that's a -3 or vice versa, then that's a hyperbola. It's very easy to identify those. So if you get an equation like that, you would say, well, I really need to complete the squares. I didn't go over a session of doing that in quadratic equations, but maybe in the future I will get you one. And the way you do it is that you combine the ones with the x squared and x in one parentheses and the y's in another. So maybe the first step, I'm going to say 3x squared minus 6x. And then I'm going to close the parentheses and say plus 3y squared plus 9y equals, and then I'm going to move the 4 to the other side, so I say -4. And then I see that I can factor 3 from both equations. So what I'm going to do is to take the 3 out and write this as x squared minus twice x, and then I'm going to leave a blank, and you will see why in a second. Plus 3 times y squared plus 3y, and then I can write plus and leave blank or just leave blank. And then the way to complete a square is that I'm going to take half of the x term. So -2, I divide it by 2, it becomes -1, and then I square it. So -1 squared is +1. So I'm going to write here +1. And many students will, by error, would say, okay, if I added 1 to the left-hand side, I should add 1 to the right-hand side. But if you think about it, you didn't add 1, you added 3. How is that? Well, there is a 3 outside. 3 times 1 is 3. So I added 3 to the left-hand side. I have to add 3 to the right-hand side to keep the equation correct. Then I'm going to move here. I'm going to divide the 3 by 2. It becomes 3 halves, and then square it. So I get 9/4. Again, 9/4 is not what I added. I added 27/4, right? Because there is a 3 factored out. So I have to add 27/4 to the left-hand side. Now, 3 times. This equation is x minus 1 square. I completed the square. How do you know? Well, what did I get when I divided the middle term by 2? I got -1, so you write -1. You don't need to check. Plus, using the same concept, when I divided the 3, I got 3 half. So it's y plus 3 halves square equals -1 plus 27/4. -1 is -4/4, plus 27/4 is 23/4. Then I'm going to divide both sides by 3, so I get x minus 1 square plus y plus 3 halves square equals 23/12. So I made up any number. That's why we didn't end up with a nice integer value. But here I know that's a circle. I knew that from the get-go. The center is 1 and -3 halves. right? H minus h, x minus 1. So h is 1. H is the coordinate of the center. Here it's negative. And the radius is the square root of 23. And then square root of 12 is 2 root 3. So you can over 2 root 3. Or 1/2 square root of 23 over 3. So that's how you identify the circle. It's very easy. We say that the circle doesn't have eccentricity. So what is that? That's what we will see when we go to check the ellipse. So here is the ellipse. The equation of the ellipse is very similar to the circle. So x minus h square. But instead of saying, I'm going to call that over a plus y minus k square over b, not over a or not over r square like we did here. Okay, so let's write this a square and b square equals 1. So what does that mean? It means that I'm dividing by a number, two different values. Okay, two different values. Here I divided by the same value, which was the radius. If A is large, so here we are going to assume always that A is larger than B. If I write it like that, it means it's an ellipse that is longer along the x than it is along the y. And if I write it as x minus h square over b square and y minus k square over a square equals 1, and in both cases here, we are going to assume A is the larger of the two, then this guy would be a vertical ellipse. Again, excuse my drawing. Both cases, this is H and K. That's what we assumed. And this is H and K. Oops, H and K. Okay. So, do you remember if you go over the equation of graphing functions, you will see something very interesting here. Here, if I look at the circle and I say, okay, how did this change from being a point here, a point at the origin? What I did is that in order to return that to be x squared, in fact, if I say I have a circle that looks like that with a radius 1, it's a unit circle, and its origin is here, then I would say x squared plus y squared equals 1, right? That's the genetic circle, right? The circle that has a radius 1 and its center is at the origin. What did I do? I multiplied the x by r squared, meaning I dilated or stretched the x with a factor of r squared, and then I stretched the y with the same factor. So it stayed the same circle, right? If you stretch the x and then you stretch the y by the same factor, your circle stays the same. All what happened is that it was inflated. And then you moved it h unit to the right if h is positive, and k units up if k is positive, and you get that. But what happened here? I inflated the x by a factor of a, so that distance here is a, and I inflated the y with a factor of b, which is smaller. You see why now I got what we call eccentricity? It's not centric. It's not symmetric about the origin. It's more inflated in the x or the y than it is on the other direction. And that's why we say this is an eccentric shape. And then I moved it h and k, so the center is h and k. So now, instead of having only a center, this center was stretched on the right and became two. And basically, we call these the two foci, a focus on the right, a focus on the left, and we call that distance uh, C. So now I have A, which is the semi major axis instead of R, right? And B is the semi-minor axis, and then I have something called C. It turns out, we are not going to waste time here doing that, is that C square here equals A square minus B square. This is the relationship between where the two foci are and the center is as compared to A and B. So every time A get more larger than B, then the C will get larger. If they come and they become the same, it becomes circle, then A would equal B and the C would be zero, and we won't have two foci. The two foci will combine and become a center of a perfect circle. As I said, you can also get this equation in terms of ax squared plus cy squared, meaning I can get an equation like that, but the 3 and the 3 would become some other numbers, okay? And you can complete the squares and find everything about it. But now, how can we calculate the eccentricity? The definition of eccentricity here is the distance from any point on the ellipse, any point on the ellipse to the focus divided by the distance between that same point and another line that we are going to write here, draw here, that is called the directrix. There is another one on the left. So if you divide this distance by that distance, which is a line perpendicular to the directrix, this ratio is the eccentricity. And that value for an ellipse is always less than 1. So between 0 and 1. Okay? So the eccentricity for an ellipse is greater than 0, less than 1. Of course, when it becomes 0, we don't have eccentricity, so that's a circle. So here the eccentricity equals 0, right? Because basically we don't have a directrix for a circle. Well, the directrix would be a tangent at any point. If you want to think about it, it's like it is attached to the circle. Next time we'll see that the eccentricity of a parabola is exactly 1, meaning the distance from any point on the parabola to the focus is the same as that with the directrix, and for the hyperbola would be greater than 1. So 0, between 0 and 1, 1, or more than 1. What we forgot to mention, or what I forgot to mention, is that sometimes we define the circle as the location of points that are equidistant from another point called the center. Meaning, if you attach a nail here and you get a rope that has a length of r and attach maybe a pen to that rope and rotate it, it's exactly like what we do with a compass. We place the center here, and if you open it with the distance r and rotate it all along, then all these points are equidistant from the circle. From the center, I mean. I'm sorry. So how do you find a circle? It's the location of a point of all points that are equidistant from another point called the center. But how do we say that point or the points on the ellipse? Okay, so now instead of having one nail and one rope, we have two nails. One is here, one is there, and then you get a rope that is longer than that distance of 2c, and maybe you take a point here, you have a pen here, and you attach the pen with a rope that goes around it, and you stretch it all the way, and you keep moving such that these points, the sum of the distance of each point to the two foci is constant. So you take, even if you take this point, the distance from here plus here is constant. Okay? So that's another way of describing points on the ellipse. Let's take an example. I'll try, I don't know, maybe I'll try to find something here so that we end up with the nice numbers instead. Do we have an ellipse? Maybe online. I need an equation. Yep, I found one. It tells you 9x squared plus 4y squared. See, different numbers. They are both positive but different. So that's an ellipse right away. You don't need to worry much. Plus 24y plus 36 equals 0. Okay, so like we did last time, I'm going to combine the 9x squared. In fact, to save time, now you see that the 9 and the negative 36 are both divisible by 9, so I'm going to factor 9 out. That would leave me with x squared minus 4x. I'm going to leave it blank. And then say plus, again, 4 and 24, I can leave 4 out. And this would be y squared. And 24 over 4 is 6y. I leave it blank. Equals negative 36. Remember what we did? We divided the x coefficient by 2, it becomes negative 2, and then we square it, it becomes positive 4. We didn't add 4, we added 9 times 4, or 36, and you add 36, and of course this would cancel both of these. I divided 6 by 2, I got 3, squared the 3, so I got 9. I didn't add 9, I added 4 times 9, which is 36. Here we divide, first of all, we are going to complete this. We already completed the square, but since I have 9, 4, and 36, then I'm going to divide by the least common multiple, which is 36, both sides. So I'm going to say x, notice when we divided this by 2, we got negative 2. So x minus 2 squared divide times 9 over 36, so it's like over 4 plus. When we divide the 6, positive 6 by 2, we got plus 3. So y plus 3 squared. When I divide by 36, I get over 9. Right-hand side, when I divide by 36, I get 1. So that's, that's an ellipse that would look something like that. Its center is negative 2 and 3, but the A here is vertical because that's 9, which is 3 squared, and the A is horizontal, which is the smaller of the two, which is 2. So I can find even the endpoints of the ellipse here by adding 2 to the x, so that becomes 0 and 3, and subtracting 2, so this is negative 4 and 3. And then I can find top and bottom by adding 3 to the x. So this is negative 2 and 6, and subtracting 3 from the y. So this would be negative 2 and 0. And these are the 4 points. If you want to find where the foci are, we know that a here equals 2, or a squared equals 4. and b square equals 9. And we know that c square, in this case, that's a b, sorry, right? We said the a is the bigger, the larger of the two. That's what we assumed. I mean, you can assume anything, but to be consistent. So c square equals 9 minus 4 equals 5, or c equals root 5. In fact, plus or minus root 5, because when you add, you get the top one. So this would be negative 2 and 3 plus root 5. And this would be negative 2 and 3 minus root 5, which is slightly more than 2.3 something. So it's more than 2 and less than 3. So it's above the 0, of course. And you can also find the directrix, but we don't care about the directrix for an ellipse. And that basically will show you how to find the equation of an ellipse or how to identify the points. In fact, we can go to the calculator. Now, I think we don't really need that, but if you try to plot it on your calculator or laptop, you should get an ellipse. Of course, much better than this potato that I drew, but uh, it would be the perfect one. I hope this was good enough. Next time, as I said, we'll do the parabola, which we already discussed when we did the quadratic equations, but maybe this time I'm going to show you maybe some another way of looking at the parabola, and then we'll do the hyperbola. I hope this was easy enough for you to understand. If you have any questions, please let me know. And if you have any topic really in math, be it like algebra, algebra 2, pre-calc, calc, that you wish that I try to present in a easier way, please let me know also in the comment sections. And other than that, I wish you all the best and I hope to see you soon. Bye.